Good morning, class. Today we're going to be looking at finding angles of a right triangle. This is concept number 6. And I hope you watched the other video about finding a missing side of a right triangle, because you're going to need that in order to do this. What we're going to want to do is say we want to find a missing angle here. We know this is a right angle, but we don't know what these acute angles are. So let's suppose it's this angle we want to find, x. And how would we do that? Well, we're going to go ahead and look at exactly what we did before when we're using trigonometry. So we have our SOHCAHTOA. Let me just write it up here. SOHCAHTOA. And we're going to use one of those functions to find this angle. So remember that this angle is sort of projecting out this way, and it's locating the opposite side here. So let's label that the opposite, and then this would be the adjacent, and this would be the hypotenuse. Okay, so this time, since we don't know the angle, we have to have two known sides, and we do. So we're going to use the opposite and the hypotenuse. If we knew the adjacent, we could use that, but we're going to set this up. So remember, the opposite and hypotenuse, let's see, that's O and H. So which one of these has O and H? Oh, this first one, so. So we're going to set this up. So we have the sine. Remember, the sine of the reference angle. This is my reference angle over here, and I'm just going to say the sine of x. So this is angle x equals the opposite over the hypotenuse, and that would be 3/8. Okay, so now I have to find an angle who has the sine of this 3/8. And we haven't done that yet. We've just basically taken the sine of an angle, but we haven't tried to do this. So in order to do this, I'm just going to give you an idea of how this would be done. This next step is really easy, but I decided just to give you the background here. So I know that 3/8, when I divide that, I get this decimal. So this is the same as 3/8 right here, 0.375. What I'm going to want to do is find an angle that when I take the sine of it, I get that. So I might start, guessing and checking. I might say, well, let's see, what's an angle? Let's suppose it's 40 degrees. So what's the sine of 40 degrees? So on the calculator, I can calculate the sine of 40 degrees, and that's approximately 0.64. And that's not the same as that. So let's try a smaller angle, the sine of, say, 30 degrees, and that's approximately 0.5. Still not small enough. So what's the sine of 20 degrees? The sine of 20 degrees is approximately 0.34. Okay, so now that's actually, I've passed it up. Like I've gone a little bit too small on my angle. So I'm just going to say, well, maybe it's a little bit bigger than that. Maybe it's 25 degrees. And I take the sine of 25 degrees and I get 0.42. Well, that's actually too big again, so maybe I'll guess the sine of, let's say, what, 22 degrees? Sine of 22 degrees is approximately 0.3746. Now, if I round that to 3 significant digits, then I get this. So 22 degrees would be the angle I'm looking for. So the angle is 22 degrees. Now, it doesn't seem like that's a very easy way to get this. So what I'm going to have to do is have an easier way. This kind of reminds me of a different problem, though, that we have a solution to. Like if I wanted to find what do I take when I square a number and I get 110? Like what number would that be? So I could start guessing and checking here too. Well, let's suppose it's 10. 10 squared is 100. Well, that got me pretty close, but it needs to be a little bit bigger than that. So 11 squared is 121. Well, maybe it's in between 10 and 11, so maybe it's 10.5 squared, and that's approximately equal to, or it actually equals to 110.25, which is just a quarter over. So it's approximately, my angle, my x is approximately 10.4. So this process is similar, is that we want to undo like a function. In this case, it's a square. So I know what to do here to find the exact answer. I have an operation I can do to both sides. I basically take the square root of both sides, and I get x equals the square root of 110. And if I put that on my calculator, the square root of 110, square root, notice a second function, second x squared, and I put in 110. That gives me 10.48 or 10.49, approximately 10.49. So it was pretty close to 10.5. So that was it. So is there something I could use here to get that angle? Well, it's kind of similar. I'm just going to want to get rid of the sign, and I want to apply that to this side over here. So I'm going to do that over here. And if I want to get rid of the sign, just do this. I just want to get rid of this sign right here. Like, what do I undo the sign? So in order to do that, I'm just going to say x equals the inverse sign. That's called the inverse sign. And then I'm going to take my 3/8. So I want to basically saying what angle gives me that sign ratio. What angle? And that is similar to what we did before with the square root. So I'm going to just take my second function and hit the sign. So now that shows the inverse sign. So the inverse of sign is a second function. And then we do 3/8. How do you enter that? 3 divided by 8. That's it. Equals. And that's 22.02. So x is approximately 22.02. And remember, I like 3 significant digits, so I would say x is approximately 22.0 degrees. And that's my answer. Okay, so like I said, this stuff you don't need to do because we have the inverse sign on the calculator. Anyway, I'll just do another quick example for you just in case you want to see that again. So let's just suppose we want to find this angle. So now I'm just going to set this up. So same steps. I'm looking at where that angle is aiming. It's aiming towards this side. So this is my opposite side, my opposite leg. And then this is the hypotenuse. Remember, across from the right angle, the hypotenuse. This is my other leg, the adjacent. Okay, now I'm going to choose to use the 10 and the 8 because those I both know both of those, and I can find this. So I'm just going to set up the let's look at that. That's opposite and adjacent. Oh, that's TOA. So I'm going to use that to set this up. So I have what I was writing there. Oh yeah, the tangent of my angle x equals the opposite, which is 10, divided by the adjacent, which is 8. Okay, now I take my inverse, and this time it's an inverse tangent. So I have tangent -1 of 10 divided by 8. Okay, so in the calculator, once again, clear. And in all of these cases, you should make sure you're in degree mode, otherwise you're going to get a different number. So we have second tangent. So that gives me, notice that -1 there, that indicates that it's the inverse. 10 divided by 8 equals, and it's 51.34. So x is approximately, if I round that off to 3 significant digits, I'm just going to keep this 51.3. The 4 is less than 5, so it's going to stay there. So 51.3 degrees, and that's it. Okay, I hope this helps, and have a great day.